Right, welcome. I think there's somewhere between 7 and 9 of you watching. I already knew of one person who can't make it live, as it were, but is going to catch up. So it's really nice to see those of you who have signed up for this. I'll go through detail, make sure everyone's up to speed with how we're going to do this. And thank you for teaching me a little thing about war crimes, GCSE history. That was not expected. I was going to teach you something as well, which is something I learned today, which is entirely unrelated as well. It's May the 1st, that's not what I learned. What I learned is that it's the ancient Celtic festival of Beltane today. That's where the May Day festival comes from. So there's my fact to you. Anyway, I'm hoping that you've probably got to a point where you've been able to sign into Socrative.com, although according to what I see, actually only 5 of you have managed so far. So I'm going to give people a little more time. Do let me know if it's proving to be difficult. But I'm just going to wait because I'm expecting if there are, well, it looks like 7 of you watching. I'm expecting 7 of you to be able to participate in the quiz. Now, it might be that there's just people randomly from around the world also watching this. That's fine too, in which case this number won't creep up. But I'm just going to wait for that number to creep up. So you go to Socrative.com, you go to student login, or you go to login and then to student, and you just type in the room number 722249. 722249. When you do so, you'll be presented with a question. We've got 6 in the room now, so that number is creeping up. I'll just wait a moment more just to check that's everyone. So there seem to be 8 people watching, 6 people in here. That might be all there is. That's absolutely fine, but I'll just wait a little bit longer. And in the meantime, as 5 out of 6 of you have done, feel free to answer question 1. So I don't know how this is going to work for all of you who are involved in this. It depends what you're watching on. I think if you're doing all of this on a phone, it'll be a bit annoying because I think every time you go off YouTube to look on Socrative, you won't be able to hear me speak unless you've paid for YouTube Premium or whatever. Whereas if you're doing this on a computer, then you should just hear me prattling on in the background and you can basically keep Socrative up. But either way, we'll just muddle our way through it. It's a little bit experimental, but we'll see how it goes. And the last thing I'll say, because I think we are all 6 of us who are going to participate, it looks like are all in. The last thing I'll say is that you might need pen and paper. I'll try and time certain questions because certain questions will require a bit of calculating. So before we move on, what we have is today paper 1 questions, and I thought I'd extend the joys so that next week, either on Thursday or Friday, probably Friday, we'll do a paper 2 quiz. And the good thing about using Socrative is that I'll be able to tell you exactly how you did. I won't sort of shame anyone publicly, but I might pay attention to some people who did particularly well. And so it's not quite the same as doing a real GCSE, but there is that same sense of rounding things off. So this is the paper 1 quiz. It's 30 questions, and I'll start. And you've all answered question 1 for me, 6 out of 6 answers in. It was how many neutrons are in this carbon atom. I should have said anytime there's an image, you can click on it, I think, and sometimes it makes it bigger if it's a little bit small on your screen. So it was an isotope of carbon 14,6C. Well, to find the number of neutrons, you do top number, take bottom number, you take the atomic number from the mass number, in this case 14 takes 6. The answer is 8. Let's see how you all did. We have mostly correct answers there. So we had 83% of you, I think an unlucky 1 person perhaps, who got that wrong. But yeah, the answer is 8. 14 takes 6 gives you the number of neutrons, and it is 8. So that was question 1. Let's move on to question 2. And these are random in their order. They don't go in specification order. It's just anything from last year, basically, anything from year 10. So here's question 2. Which of the following statements about contamination and irradiation is not true? We have A, contamination is the unwanted presence of radioactive atoms on materials. We have B, the hazard from contamination is from the decay of the contaminating atoms. We have C, irradiation is the process of exposing an object to nuclear radiation. And we have D, an irradiated object becomes radioactive once exposed to radiation. You are lucky in this case for the one that is not true. Take your time answering. I'll be able to see when you've all answered, but choose which one you think is not true about contamination and irradiation. Half have answered so far. Thank you for your patience if you're waiting. There's kind of no rush in these days we're living in, but it's, yeah, I do want to make sure everyone has full time to answer. So just thank you for your patience if you are one of those people who answers quickly. Right, we have 6 out of 6 answers. Let's see how you did. I think this is one of many questions that will come up that actually is pretty tricky. I thought this one was certainly one of those. Let's see how you did. I'm not expecting everyone will have got this right. And no, your answers were divided. You can see if you chose D, it is correct. It's the one going green on my screen. I think you can see that. It might even appear on your screen when I do that. But yeah, the one that isn't true there is when something is irradiated, it becomes radioactive. Because irradiation is just like, I don't know, like having an X-ray. You have the X-ray, and for the time you're in that room, you are being irradiated. But when you leave the room, you are not radioactive. You don't have any radioactive atoms on your person. That would be called contamination. So it was D that was incorrect here, and D was the answer. Question 3. Which of the following pairs of energy resources produce the most carbon dioxide when being used? And here are the pairs: A, coal and nuclear fuel, B, geothermal and tidal, C, oil and coal, or D, nuclear fuel and hydroelectricity. Which of the following pairs of energy resources produce most carbon dioxide when being used? Give you a moment to answer. And you wouldn't take long, Jasmine, to use the word oof in relation to your own performance. Do not worry, these questions are meant to be difficult. There's a mixture. Some are less difficult than others, but everyone, I think everyone doing this will make mistakes along the line. So don't worry, and you are not by any stretch bad at physics at all. One more person to answer. So we're looking for which of the following pairs of energy resources produce the most carbon dioxide when being used. Some of these you're looking for, I think, a best fit answer. I mean, you could make arguments and look at these questions in different ways, but I think there's a clear best answer here. I'll just wait for one more person to answer, and that person has. How did we do? 100% correct. Really well done. Yeah, the ones that produce the most carbon dioxide when being used are oil and coal. Really well done. Question 4 coming up. Right, this is one where I'm hoping you'll be able to click to make bigger. I can as well, and I will in a moment. The question is, which row correctly shows the states of matter in the diagram below? So we have 3 states of matter diagrams, and then we have 4 choices, A, B, C, and D, as to which represents which. I hope that's clear enough. I'll give you a moment to answer. There's a lot of A's, B's, C's, and D's floating around in this, but I hope in the end you see how the system works. Which one is a correct depiction of solids, liquids, and gases labelled correctly? 4 out of 6 answers so far. And 6 out of 6 answers. Let's see how you did. Once again, we have unanimity and correct answer from everyone. Really well done. Yeah, solid, liquid and gas. This one happened to be in order A, B, C. The particle diagrams of each one. So we know everyone in the room has at least got 2 out of 4. Some of you might still be out of 4 out of 4. If so, well done. This is question 5 coming up. Which of the following is an example of irradiation from an external source? I'm wondering if I gave things away here, but we'll see. Here are the choices: being exposed to X-rays in a hospital, breathing in radon gas, drinking a liquid that contains a radioactive material, or having radioactive material present on the skin. Which of those 4 is an example of irradiation from an external source? I've got 3 out of 6 answers in so far. Just waiting on one more answer. I think 5 out of 6 at the moment. And 6 out of 6. I'll see how you did. Most getting this. So yeah, it's the X-ray one. This difference between irradiation and contamination. Irradiation, you're simply exposed to something radioactive, but that material doesn't remain on you once you've been removed from that situation. Whereas contamination, you're exposed all the same, but in that exposure, you're also left with radioactive material on you, and that's called contamination. Irradiation, contamination, and yes, X-rays are a good example of irradiation. That's question 5. So on to question 6. Another table to enlarge. Do put in the comments if the tables are too small to see. I don't know if there's been any guesswork here. I'm not quite sure how it comes out with you. But there's a table to enlarge, and it says a radio transfers 40 joules of chemical potential store to 28 joules of useful energy. Which row of the table is correct based on this information? And on that table, you're given efficiencies and amounts of energy loss. Which is the correct pair of answers there? You might need a bit of time to do some calculation. That's fine. That's why I said have a calculator to hand and a piece of paper. But come up with what you think are the right answers. And again, I'll wait till we've got 6 out of 6 in before I reveal an answer. Four out of 6 have answered so far. And we have 6 out of 6 answers. So yeah, you had to work out an efficiency here, or just work out which was the correct efficiency, and also calculate an energy loss from the information that we were given about this radio. So let's see how you did. Everyone correct. Really well done. Yeah, the efficiency was 0.7, and the amount of wasted energy amounted to 12 joules. I think 40 had gone in, 28 came out, so 12 joules were kind of lost to the surroundings along the way. Really well done. This is question 6 coming up. What potential difference is needed for a current of 1.5 amps to flow through a 60 ohm resistor? You have 4 choices. One of them was correct. Some calculation probably needed once again. And of course, you need to know the right equation to use. And this is where physics gets hard. So yeah, let's see if you can work that out. One more answer, I think, waiting to come in. Don't rush if you are that one person, that's fine. Like I say, we're hardly time pressured in these times we're living in. I want people to have the right amount of time to answer these. Right, I seem to have 6 out of 6 answers. Let's see how you did. Right, we have a majority getting this right again. The equation to use here was V equals IR. Potential difference equals current times resistance. It was one of the first electricity equations I taught you, but that was well over a year ago. So V equals IR, you have a current of 1.5 multiplied by a resistance of 60, 1.5 times 60, 90 volts. Really well done if you're amongst those who got that. Next question. Another table one. Which row below shows the correct changes in energy stores when a petrol-powered car accelerates up a hill? So yeah, you need to identify the correct changes in energy stores when a petrol-powered car accelerates up a hill. Make your choice from A, B, C, or D on the table. Three out of 6 answers so far. There we go, we have 6 answers come in. So a little bit tricky, again, something you've not thought about for a while. But yeah, car accelerating up a hill, petrol powered. And anytime a question in physics sort of drops in things like petrol powered, it is significant. And I think one thing I can say to I think everyone who's watching here is you got so good at just picking up those little clues that are dropped into any physics question. In physics questions, no word is sort of put in there sort of without there being a meaning attached to that word. Let's see how you did anyway. So everyone correct. Really well done. Yeah, in this case, there'll be an increase in the kinetic store. We were told it accelerates. That was a key word. As soon as it accelerated, you knew it was getting faster. As soon as you knew it was getting faster, it was increasing in its kinetic energy. It was going up a hill, so it was increasing gravitational potential energy. And its chemical store, that was what was in the petrol. So as it was using up petrol, it was decreasing in its chemical store. And that's why answer D was correct. You clearly all were able to work that out. Really well done. Question 9 coming up. How should an ammeter and voltmeter be arranged next to a component in a circuit? So you're wishing to measure the current and the potential difference associated with something in a circuit. How do you connect them? A, B, C, or D? I think you can read them for yourselves on the screen. Two more answers to come in. Your choices are ammeter in series, voltmeter in parallel. Ammeter in series, voltmeter in series, that's A. Ammeter in parallel, voltmeter in series, that's B. Ammeter in series, voltmeter in parallel, that's C. Or ammeter in parallel, voltmeter in parallel, that's D. A, B, C, or D. Still waiting on 2 answers, I think. That's a 5th answer come in. And a 6th answer come in. Let's see how you did. Everyone correct. Really well done, yeah. Ammeters go in series, they go in the loop with the thing you're measuring. Voltmeters go in parallel with whatever you're measuring, in their own separate loop across the component being measured. Really well done. Question 10, a third of the way into the quiz. Some circuit symbols, which of the following is for an LDR? A, B, C, or D? I'll give you a moment to answer. Six answers in. Now, I have to say the correct answer here, as we're about to see, is not quite how we drew it, but certainly recognisably the same thing. So let's see how you all did first. There we go, you all got the right answer, C. But yes, in our version of an LDR, there wasn't a line going straight through the middle of that central resistor, because that makes it look a little bit more like a fuse. But it's clearly recognisably the same thing, as you all saw. Well done. Next question. A microwave oven transfers 450,000 joules of energy in 10 minutes. What is the power rating of the microwave oven? So a microwave oven transfers 450,000 joules of energy in 10 minutes. What is the power rating of the microwave oven? I'll give you a moment to work that one out. I'm just nipping off screen to get my mini whiteboard in case I need it. Three out of six answers so far. Take your time if you want to get it right. Don't worry if you are keeping the one person that's taking longer than everyone else. That's absolutely fine. It really doesn't matter today. Five out of six answers so far. And 6 out of 6, so I can see how you did. Let's have a look. Right, 50-50 on whether people got this right or got it wrong. So if you got it wrong, you're clearly in good company. So don't worry if you didn't. But I suspect I know what will have happened. And it's a unit conversion, isn't it? So I think everyone's done the right calculation. That's sort of the good news. So if this were a real exam question, not that that matters anymore, but it might have been worth 2 or 3 marks. Well, even those who got this wrong have still got 1 mark. But yes, what you do is you do power is energy over time. But it's about using the right energy and the right time. Now, in this case, the energy is fine. That's in joules. It was 450,000. But the time was in minutes, 10 minutes. So we have to convert that into seconds. So 10 times 60 is 600. So yeah, in your power calculation, it's 450,000 divided by 60 to get to the answer of 750 watts. Well done to the half of you who got that. Commiserations to the half who did not. Don't forget unit conversions. Next question. Which of the following is true when a body melts or freezes? Answer A, the body will change state from a gas to a liquid. Answer B, there will be a large increase in the temperature of the body as it melts or freezes. Answer C, the change of state will take place without a change in temperature. Answer D, the mass before the change will be greater than the total mass after the change. The total mass before the change will be greater than the total mass after the change. Which of those is true for when a body melts or freezes? Two more answers waiting to come in, I think. Which of the following is true when a body melts or freezes? A, the body will change from a gas to a liquid. B, there will be a large increase in the temperature of the body as it melts or freezes. C, the change of state will take place without a change in temperature. Or D, the total mass before the change will be greater than the total mass after the change. We have 6 answers in. Let's see how you did. All correct. Really well done. I was prepared to show you on a graph how and when that happened. I don't think I need to. Really well done. Next question. 13. How much energy is stored at a kinetic store when a toy rocket of mass 3 kilograms moves at 20 meters per second? How much energy is stored as a kinetic store when a toy rocket of mass 3 kilograms moves at 20 meters per second? You have 4 choices, A, B, C, or D. 30 joules, 60 joules, 600 joules, 1200 joules. Make your calculations. Just waiting on one answer, I think. I have 6 out of 6 answers there now. Let's see how you did. Almost all correct. Well done if you got C, 600 joules. Yeah, just to go through briefly where it comes from. Kinetic energy is about knowing your equation first. EK equals a half mv squared. There were no units to convert here, so it was a half times by 3 kilograms times by 20, but perhaps forgetting the squared is something sometimes people do. You run that through a calculator and it comes out as that answer, 600. Well done if you got it. Next question. This is question 14. Which of the following statements about the atom is not correct? A, the atom has a positively charged nucleus around which electrons orbit. B, most of the mass of the atom is in the nucleus. C, the radius of the nucleus is about 1/10,000th that of the radius of the atom. Or D, electrons in orbit around the nucleus all have the same energies. Which of those 4 statements is not true about the atom? 4 out of 6 answers in at the moment. Yeah, you're looking for the statement that's not true about the atom. A, B, C, or D. All answers in, let's see. Most correct again, so well done if you're amongst the majority there. Yes, it isn't true that electrons all have the same energies. They're called energy levels or orbits, aren't they? So as you go into one energy level compared to another, the amount of energy those electrons contain is different, and that's why they're known as energy levels. If you do A-level physics, you'll actually learn a lot more about calculations and transitions between energy levels, and how when electrons do transition between energy levels, sometimes they give out light and you can work out the color or the frequency of that light. Some really interesting things you can do once you know a little bit more about energy levels. Next question. Halfway into the quiz now. Question 15, you have a diagram. Which process is being shown? Well, it says below. I think for most of you it's to the side. It depends what screen you're looking at. But there's a diagram. What process is it showing? Is it showing alpha decay? Is it showing beta decay? Is it showing nuclear fusion? Or is it showing nuclear fission? A, B, C, or D? All 6 answered. I'll see how you've done. Most correct on this. I actually thought some of you would have put about alpha decay. I thought that might have confused. So well done for avoiding that. That was there to sort of trap you. Yeah, this one's nuclear fusion. You have 2 light nuclei. In this case, it's 2 isotopes of hydrogen. In fact, it's deuterium. It's where you've just got 1 proton and 1 neutron in the nucleus. So it's an isotope of hydrogen and another of the same isotopes of hydrogen fusing together to form the next heaviest element. You can see the element that they form has 2 protons, and that makes it helium. This process is one of the many processes, fusion processes, happening in the sun right now, causing the sun to shine. This is nuclear fusion. And so well done if you got it. 2/3 of you did, so well done if you're in those 2/3. Question 16. Which of the following best describes the process of nuclear fission? Here are the choices. A, the splitting of an unstable heavy nucleus into smaller nuclei by a beta particle. B, the splitting of small nuclei by fast-moving protons. C, the splitting of an unstable nucleus into smaller nuclei by slow-moving neutrons. Or D, the joining together of 2 smaller nuclei to make a bigger, more stable nucleus. Which of those best describes the process of nuclear fission? I'll give you a moment to answer. Half of the answers in so far. Yeah, one of those is the best description of nuclear fission. Four out of 6 answers. And all answers in. Let's have a look. Very unlucky. In both of the descriptions chosen, and you can see the majority, 2/3 again, did get it right. It's been a very good rate of success on these questions. Well, the first one was very plausible. It is indeed the splitting of an unstable nucleus. But the thing that causes it in most cases is a slow-moving neutron, not a beta particle. And a beta particle, if you remember, is another word for an electron. It was given that name, and then we subsequently discovered it was an electron. But yeah, not by beta particles, it's slow-moving neutrons that cause this fission process to happen. Question 17 coming up. Which of the following is correct for series circuits? Either, and this is A, the current changes in a series circuit when it flows through a resistor. B, the potential difference across each component is equal to the cell voltage. C, the potential difference of the power supply is shared between the components in series. Or D, the net resistance decreases as more resistors are added in series. A tricky question this, people always find electricity hard. I'll give you a moment to answer. We've got all answers in. I'd be really surprised if everyone gets this one. I think this is the kind of one that will certainly trip people up, but let's see. Oh, well, that shows how well I know all of you. All correct, but I must have taught you well. Yeah, the potential difference of the power supply. So let's say that has 12 volts to offer, and let's say there's 3 components. Well, if they're all equal in terms of their resistance, they'll get an equal share 4 volts. But the key is this idea that if you have 12 volts being supplied, 12 volts will be used somehow. So really well done. I don't need to say much more than that, do I? Question 18 coming up. Which row below correctly describes what happens when a gamma ray is emitted from a radioactive nucleus? Choices are these. The mass goes down by 4. The atomic number increases by 1. There is no change in the mass or charge of the nucleus, or the nucleus becomes less stable. Which row below correctly describes what happens when a gamma ray is emitted from a radioactive nucleus? Make your choice. Six out of 6. Let's see how you did. All correct. I'm really impressed by that. We've not talked about radioactivity for quite some time. Nevertheless, you remember that gamma, yes, it's, I often called it a dry sneeze when I was making an analogy with sneezing and radioactivity. Yeah, nothing comes out except energy. So there's no change in the mass, no change in the charge. You're not losing protons or anything like that. Really well done. Question 19 coming up. Which of the following statements is correct about atomic models over time? A, the model of the atom hasn't changed in over 200 years. B, the plum pudding model replaced the nuclear model of the atom. C, the Bohr model was replaced by the nuclear model of the atom. Or D, new models of the atom are accepted when new evidence proves them to be better. Which of those is correct about atomic models over time? One more answer to come in. Which of those correctly describes how atomic models change over time? 6 answers in, let's see how you did. Most correct, and I thought in this B, C and D all looked pretty plausible. No, the Bohr model replaced the nuclear one. It sort of added the detail of electrons being an energy level, so it's not C, it is D, this idea that as soon as new evidence comes along that shows that the previous model wasn't true and that the current model is better, then that new model replaces the old one. Yet new evidence always causes models to change, causes science to change. Next question, this is question 20. How many electrons are in this atom of carbon? It's that same atom you've seen before. How many electrons are in it? Answers 6, 8, 12 or 14. A, B, C or D, 6, 8, 12 or 14. Make a choice. Six answers in. Most correct. So remember that the atomic number, the bottom number, is the number of protons. And maybe this question should have said, assume it's not been ionized. This is a neutral atom, just a normal atom. But yes, if there's 6 protons, 6 positively charged particles in the atom, then there's also 6 electrons, 6 negatively charged particles in that atom as well. Next question. So this is question 21 coming up. Question 21. Which statement regarding nuclear fission is correct? A, spontaneous fission is very common in nature. B, when fission occurs, 3 nuclei and 2 neutrons are produced. C, all of the products of nuclear fission have kinetic energy. Or D, the reaction in a nuclear reactor the reaction in a nuclear reactor in a power station is uncontrolled fission. Which of those is correct? Four answers in so far. I don't think this is particularly easy. I think it requires having some deep knowledge of fission, but we'll see how you do. A, B, C or D, spontaneous fission is very common in nature. B, when fission occurs, 3 nuclei and 2 neutrons are produced. C, all of the products of nuclear fission have kinetic energy. Or D, the reaction in a nuclear reactor in a power station is uncontrolled fission. We have 6 answers in, let's see how you did. All correct. And every time I think your answers are going to be split, you prove me wrong. That's a really, really good answer from all of you. Well done. Question 22 coming up. Which of the following is the energy store of a moving body? Is it A, elastic potential energy, B, gravitational potential energy, C, kinetic energy, or D, thermal energy? Which of the following is the energy store of a moving body? Six answers in, and 6 answers correct. Well done. Question 23 coming up. You have a circuit. You can click on the circuit if you want to. It doesn't reveal much more. It's quite clear on my screen at least. If the current leaving the battery in the circuit below is 2 amps, then what is the potential difference of the battery? You have 4 choices. You have 10 volts, 20 volts, 30 volts, or 40 volts. Choose which you think is the correct answer, having done some calculation. Right, all 6 of you have answered. Let's see how you did. Oh, that's really well done. Yeah, so I won't go through it at length. I was preparing my board for doing so. But yes, you've all used V equals IR. You recognise that the current was 2, that's fine. The current in a series circuit is the same throughout. But you've recognised that you need to work out the total resistance. In this case, it's 5 plus 10. So there's 15 ohms of resistance. There's 2 amps of current flowing through, so you do 2 times by 15, and you get 30. Really well done. Question 24. Which of the following statements is correct regarding density and different states of matter? A. Solids are the most dense, then gases, then liquids. B. Gases are the least dense as they have the lowest mass per unit volume. C. Liquids are the most dense as the particles in them are closest together. Or D. Gases and liquids tend to have similar density values. Choose which of those you think is true regarding density and different states of matter. Six out of 6 answers in. All correct, yeah. Gases have the lowest mass per unit of volume, and that makes them the least dense. Really well done. Question 25 coming up. The IV graph shown below or opposite is for which components? Your choices are A, a filament lamp, B, a resistor, C, a diode, D, an LDR. What is the IV graph representing? All answers in. All answers correct. Well done. You know your IV graphs well. The diode being this component, I'm just going to grab Raggedy because she's here. And she's not said hello in a while. Here's Rags. But what I was saying was that, yes, the IV graph of a diode shows how it behaves. That it works in the forward bias. In one direction, it will switch on, it will work, it will allow current through it. But when you connect it the other way around, in the reverse bias, in the reverse direction, it simply doesn't operate. And that makes it fantastically useful in complex circuits. It allows you to make decisions electrically, and that's how computers and calculators are formed. So really well done, all of you who got that correct, which is everyone. I'll put Ramsey down. That's what you'd like to see. Next question. Question 26. You have a circuit again. What is the resistance of bulb B in the circuit? You have 4 choices. Is it 6 ohms, 10 ohms, 20 ohms, or 32 ohms? Do some calculation, come to an answer. What is the resistance of bulb B in the circuit? One more answer to come, I think. 6 answers in. Difficult one, I think, but let's see how you did. Well, perhaps not. And to get that, don't underestimate what you've understood. You've understood that current split, so you knew that 1 amp of the current went in the first branch, therefore the 0.6 went down that second branch where B is. But you've also understood that each loop of the circuit gets 12 volts. It'd be very easy to have split that into two and to use 6 volts there. But yes, once you know it's 12 volts and you know it's 0.6 amps, then you're doing R equals V over I. You're doing 12 divided by 0.6. And when you do that, it comes out as 20 ohms. Really, really well worked out. Well done to you all. Next question. 27. Only 4 to go now. Which row correctly describes the rate of cooling through the walls of a house? Sorry, which row correctly describes how the rate of cooling through the walls of a house could be increased? A, B, C, or D? If you want to increase the rate of cooling through the walls of a house, which is the correct way of doing so? Half of answers in so far. Clearly this is giving some of you some things to ponder, such as the meanings of these two ideas. One more answer to come in. All answers in, let's see how you did. Some discrepancy here, still 2/3 got it right, so well done. Yes, if you want to increase the rate of cooling through the walls of a house, well, thickness of wall you'd want to decrease. You'd want a thin wall if you want to increase the rate of cooling, thin wall. And thermal conductivity, you'd want more heat to conduct through, so you'd want to increase the rate of thermal conductivity, and that's why the answer was D. Lot to understand really to get that question right. 3 more questions. Question 28. Which row describes what happens to the behavior of particles in a gas when a fixed volume of the gas is heated? So you have a fixed volume of gas. What happens to the behavior of the particles in a gas when you heat a fixed volume of gas? A, B, C, or D? Again, choosing from rows in the table. Everyone's answered. Let's see how you did. You all did correctly. Yeah, you increase the gas, you increase the speed of its particles, you increase the pressure because those particles are hitting each other in surfaces with more force. And of course, if you increase something's speed, you increase its kinetic energy. So it had to be rho d, increases, increases, increases. Really well done. Question 29. A gas kept at a constant temperature has a volume of 40 litres when kept at a pressure of 800,000 pascals. What volume will the gas occupy when the pressure is reduced to 160,000 pascals? And I think this is one of the tougher questions on this quiz. I'll give you a moment to try and work out the answer. Right, we have 6 answers in. Let's see how you did. I'm impressed by the speed, I have to say. I thought that would take more calculation. Maybe there was some guesswork there, but yeah, this divided people again. But again, we've got 2/3 of people getting it right. The reason this was harsh was it relied on an equation you get given on the data sheet. Well, I didn't rely on it necessarily. There are other ways of working it out, but on the data sheet, you're given this little fact about gases. It's kind of barely an equation. It doesn't feel like an equation in the traditional sense. You get told that for a gas at constant temperature, PV equals constant, and that's on the data sheet. PV equals constant. Well, then it's about knowing what to do with that. So we're told the first case scenario about that gas. We know a pressure. So we know that P is 800,000. And we know that V is 40. So you do 800,000 times 40 and you get, I think, 3,200,000, do you? Something like that anyway. No, you don't. You get 32 million. You get 32 million. So that is the constant. And then you can recycle that constant in the second scenario. So in the second scenario, you had the pressure was 160,000, but we didn't know V. So 160,000 times V equals that constant, 32 million, sorry. Then when you rearrange that, you work out that V is 32 million divided by 160,000. And that's how you come to your answer. That's a bit blurry on screen, I think, but I hope you saw what I did there. And yes, that brings out an answer of 200. Really, really well done to those who got it. And so we end with one final question. A current of 4 amps flows through a 10 ohm resistor. How much power is dissipated? Choices are A, 2.5 watts, B, 40 watts, C, 160 watts, D, 400 watts. A current of 4 amps flows through a 10 ohm resistor. How much power is dissipated? Right, we have 6 out of 6 answers. And again, that 2/3 correct response rate is really very impressive. This question, again, a difficult one. It relied on a pretty obscure equation, one of the ones people most readily forget. P equals I squared R. We had a current in the question, we had a resistance in the question. This is the one that leads most easily to a power. There are other ways of doing it in 2 steps, but this one gets you there straight away. So yeah, the current was 4, and that's squared, times by the resistance, which was 10. Well, 4 squared is 16. 16 times 10 is 160. Very impressive once again if you got that. Now, before I reveal some, well, have a look at some final scores, I might not necessarily reveal them. Just answer me a question, as long as 1 or 2 of you have answered, I'll know. Can you see your score already? I just want to know, can you see your final score, yes or no? Right, we have some no's coming in, so thank you. So it's down to me to reveal them. Now, I don't know, I'm about to see who's been watching all this time, because actually I only know the people that do the comments, but I'm not going to go through a list and tell you how you all did. For that reason, because, you know, someone might have done conspicuously worse than some others and might feel bad about that. I doubt anyone's done badly at all. I'm going to have a look for myself. I will let you know, but I'm just interested to see for myself how you did. So I think I end the activity. And then I get my report. Let's see how you did. So, right, well, I think there's good news all around. So I've got, and that's right, I've got 6 people in the room. I've got 6 people in the room. And here is the good news. I'm going to apply last year's grade boundaries to these. The lowest, shamefully lowest score was 83% that 2 of you got. That's shameful, isn't it? No, that's absolutely fantastic. To say that the lowest score in the room is 83% is absolutely brilliant. And yes, if I applied last year's grade boundary, last year's paper 1, well, you only needed, I say only, you needed 76% to get a grade 9. So I know this isn't a real GCSE, but I'm going to make that claim for you all now. You all just got a grade 9. That is absolutely possible with the people in the room, by the way, but that is really, really impressive. Yeah, 83% lowest score. We had an 87%. Sorry, we had an 80% lowest score, still a grade 9. We had 80. We had 83 from 2 people. We had an 87. We had a 90% the highest score, apart from someone who's playing along, who was a teacher, and I would expect got 100%. Superbly well done to you, though, sir. But yeah, the other scores in the room, 90% highest, 80% lowest. That's hardly a huge spread. So I think everyone in the room can feel really quite impressed with how they did. Percentage-wise, it's a grade 9. We'll take that. We're halfway through, of course. So let me wrap up by saying this. This quiz, I'll keep it available. So I'll put it up for anyone who missed it, an email out. There'll be an email you 6 can ignore, actually. I'll send out an email saying if you want to catch this up, because there's a few who I know will want to. I'm going to leave this quiz open for them to try over the coming few days. But for the rest of you, I think next Friday we'll do similar, except it will be paper 2. So it will be forces, it will be waves, it will be magnetism and electromagnetism, and you should be super good at that. And it will also be space physics. And again, I'll do a paper 2, and it's a bit like rounding off the course with our 2 real papers. Of course, less riding on it, and it's like a different format, but hopefully it works well. So for now, have a really good week. Look out for your emails, especially as Friday comes up, because I'll give details of how and when we'll do the quiz, hopefully very similarly to this. Thank you so much for tuning in once again. Have a really nice weekend, and bye for now. Bye.